Hello everyone. In the last lecture, we have seen the introductory part for the convolutional course. So these are all slides which already we have seen. We have seen the representation methods, state diagram, then the code tree, and the tree list diagram. We have seen the simplified format for this one also. How to go for the simplified format. So this is what the simplified format for this kind of structure we can say. Now let's proceed. If think that let's say with one of the example for the same convolutional encoder circuit, if the example is like if we provide let's say the input bit as a 101, means it is of 3 bits, and the output bits for each bit will be is based on the value of x and y. So how to calculate this x and y? That is by using the expression c XORed with b XORed with a. So whatever the bit we are having in C, that will be XORed with B as well as A. So that's why you can say the adder will be with the 3 arrows coming over here. This is second and this one is third. Similarly, Y is C XORed with A. So it is from this particular line over here and again from A. This is how the Y will give the corresponding output, that is C XORed with A. So with the help of the let's say the input data, if it is with 3 bits, we expect that the 3 into 2 means for each bit we expect 2 output bits for each single bit. So 3 into 2, that means 6 output bits will be there for the total 3 input bits. But right now we can observe here these are the first 6 bits, but the next 4 bits are been added over here. That is to determine the initial level of the system. Means initially we assume that the flip-flops or the memory elements are with the 0 values, and at the end of the bit stream, input bit stream, we expect the same kind of thing. So that's what this purpose is taken to add this next 4 bits. So in order to get these next 4 bits, we need to append the zeros to the existing stream. Means for the 101 input bit, if I add further 2 zeros, I will get total 10 bits. Means 5 bits will be at the input and total 10 bits will be at the output. How to calculate this 10 bits? So it will be with the formula, that is coded output sequence will be of length. It means that encoded output bits. How many encoded output bits will be there? That will be n into L. So for this constraint length is 3, number of output bits are 2, and the memory elements, active memory elements will be only 2, that means B and A, because C is just carrying the input bits one by one. Now based on this, actually these 10 bits will be displayed. Now let's look at what exactly the status for C, B and A, as well as the output bits X, Y. Now these output bits will be in the sequence of X, Y only. That can be observed over here, that specifically we are shifting this particular arrow from V1 to V2. Okay, that is what expected. If we shift it like this, it is expected that the V2 will be taken first and then V1. Okay, right now here it is the sequence like V1 V2. Okay, and if someone goes for let's say in opposite direction, then it will be V2 and V1. Okay, so this is what the simplified, we can say, the output structure. So here also you can observe that it is V1 V2. Now with respect to this particular diagram, let's proceed how it will give the values of x and y. So first input bit is 1, is what provided over here. It will be accepted in C, so it will be accepted in C first of all. Status of B A will be 0 0 initially, means in short initially C B A all will be 0, but when we provide this input bit 1, so it will be traversed from left to right only. First input bit will be 1, so 1 0 0. This is what the status for CBA respectively. So based on this structure, if we calculate the x, it is nothing but XOR of C, B as well as A. So after XORing all this, 1 XORed with 0, 0 XORed with 0, it will give overall output for x as a 1, means 1 plus 0, that is 1, again 1 plus 0, that is 1. So it will give the value of x as a 1. Similarly, value of y will be C XORed A, means this 1 XORed with 0, that will give 1. So this is how for the first input bit 1 we can calculate the values of x and y as a 1 1. So that is what for this one it is 1 1. Similarly, let's consider the next input bit, that is 0. So next input bit is 0. So 0. So based on this 0, again we need to find out what will be the status for CBA. So when the input bit is accepted from the left side itself, so C will have the status that is 0. The earlier contents of the C, that is 1, will be shifted to B. So B will have the value 1. Content of B will be shifted to A. So that's why recent status will be 0 1 0 for CBA. Based on again values of CBA, we can get the values of x and y by following this particular expressions. This is how when I add C, B and A, I will get x. So 0 XORed with 1, that is 1. 1 XORed with 0, that is 1. So x will be 1. Similarly, when we add C and A, that is actually giving y. So 0 XORed with 0, that is 0. So that's why 1 0 will be the x and y. So 1 0 will be the output bits corresponding to the input bit 0. Similarly, the status can be observed for the next input bit, that is 1. So it will be 0 0. So for the next input bit, it will be again accepted to the C. So contents of the C will be shifted to B. Contents of B will be shifted to A. So right now the status for CBA will be 1 0 1. So based on this, x will be 1 plus 0, that is 1. 1 plus 1, that is 0. Since it is XOR addition. Remember this one, it is XOR addition. And the next is y. So to calculate the y, again 1 XOR 1, that is 0. So that is how it is coming 0 0 values for the next input bit. Now these 4 bits, next bit 4 bits can be calculated with the help of this final expression, that is 10 bits we expect. But to get this next 4 bits, I need to append here the 2 zeros. So that's what done over here. So these 2 zeros will do the task of providing all zeros values to the CBA. That means in short, to achieve the initial condition. So in the exam, if someone just calculate this particular values, then also it can be considered as a correct one. So this is how we can get the values of output bits. So these output bits are nothing but called as a encoded output. Okay, so this is how the convolutional encoder will respond. Now this is the, we can say, the first technique of calculating the encoded output from the given input bit string with the help of the convolutional encoder circuit. Now this is the kind of we can say the state table, and from the state table it is quite easy to prepare the state diagram. Now let's proceed for the first representation method of the convolutional encoder. So that is nothing but the state diagram. Let's proceed with the state diagram, and we will see how to represent this entire state table in terms of the state diagram. So here you can just find out that this is what the state table just now we have seen. And if someone want to create, let's say, the state diagram in this particular manner from this particular circuit, let's have the simplicity to this particular diagram. We just arrange it in a different manner, means let's say if it is present state is B and A, because these are the active, we can say, the flip-flop or the shift register which will decide the state of the encoder. So that's why BA is the sequence which we are going to follow. So for each input bit, the input bit will be either 0 or 1. So that's why 0 1 0 1 0 1 is repeated over here. Now if the state of this B and A, let's say it is 0 0, next time it may be 0 1, next time it may be 1 0 and 1 1. So these are the four possibilities for this BA. All these four possibilities are for the either 0 or 1. That's why the total 8 possibilities we can observe over here. Based on all these values, for CBA we can calculate the XY. So earlier in the earlier session we have seen how to calculate the X and Y based on the values of CBA. So this table is nothing but the state table. This can be prepared in consideration with the earlier concept itself. Now the next thing is how to prepare the next state. Okay, now the next state is quite simpler. When we say the next state, it means it is arranged in the kind of format to get the, we can say, the with respect to the shift, what is the exact status. Let's say if the input bit is 0, that is 0, earlier BA is nothing but with the 0 0, so output bits will be obviously X and Y will be 0 0. The next state for the BA, that is again 0 0. It means with the influence of this C as a 0, present state was 0 0 and the next state is again 0 0. Okay, similarly when we say input bit is 1, for B and A it is 0 0, output will be XY as a 1 1 with the help of this expression. But here let's see here what exactly the actual process. So B and A, right now the status of B is 1. So obviously when the C is 1 and B is 0, A is also 0. This is what the current status. So when we say that in the next iteration, this value of C that will be shifted over here. So this 0 will be changed to 1 and this 0 will be shifted over here. Since its earlier state was 0 and right now it is with the again 0, but that is shifted from B. So that's why the B and A will have the values as a 1 0. So that is what the next state. So this, how to prepare this next state in a simplified way, that also we will see. But right now this is some kind of relation which you can just observe over here. So in short, whatever the CB, that will be BA over here. Okay, let's say here CB means 0 0, again 1 0, CB will be acting as the next state. Next 1 1, that is CB will be 1 1, 0 1 CB, then it will be acting as the next state as a BA, then 1 1. Okay, like that it will be prepared. So this is how the simplified technique to prepare the state table. Now let's look at how to write down this particular diagram. This is nothing but the state diagram, that is in short called as a SD. Okay, we will see for this particular diagram there are certain values which are mentioned over here. Means this is the state with the 0 0. So for 0 0, when we say the input bit is 0, this is indicated with the continuous line. So when the input is 0, so for 0 input, when the present state is 0 0 0, its next state will be 0 0 itself. That's why the arrow is directed to 0 0 itself. But what about the output bits? So these are the output bits which are specified just below this corresponding input bit. Now the next is if for the 0 0 present state, if the input bit is 1, so if it is 1, this is what's shown over here, then the next state for this one is 1 0. So this is what the next state. So this is the next state, and the output will be what? 1 1. So this is how it is actually prepared for entire diagram. Now let's consider the random case. Let's say it is 0 1. Okay, if I consider the 0 1 state, so for the 0 1, when the input is 0, output will be 1 1. So when the input is 0, okay, here it is mentioned. So when the input is 0, output will be 1 1. So output will be 1 1. But what is the next state? It is 0 0. That's why the arrow is directed over here to the 0 0 state. This is considered for the input bit 0. Now let's consider for the input bit 1. So when the input bit is 1, for the 0 1, the next state will be 1 0. That's why next state will be 1 0 when the input bit is 1, and the output bits will be 0 0. So that is what mentioned over here. This is how the state diagram will be prepared in a simplified way for the given convolutional encoder. In the next session, we will see how to prepare the code tree, or it is also called as a simple tree diagram. So if we just look at the earlier example, it can be well traced with the help of the state diagram also. Means let's assume that the input bit is 1 0 and 1. That is the output we expect. So in obviously the initial condition every time will start from 0 0. So for 0 0, when the input bit is 1, this is what the output bits. So output bits will be 1 1. So 1. So when it reaches to 1 0, again it will track for the 0. Means from the 1 0, the continuous line will be followed. So it will give the 1 0 output. So it will be 1 0. Again from 0 1, since it reaches to 0 1 state, again from this one it will look for the input bit 1. So input bit 1 means the output will be 0 0. So this is what the, again the same kind of output which we got in the earlier stage, that is 1 1 1 0 and 0 0. Okay, the same output we can track from the state diagram also. So thank you everyone. This is what all about the state diagram representation for the convolutional encoder.